Hey team. So I was just factoring out this chunks function that we actually wrote as part of Advent of Code challenge a little bit ago. Here we are, chunks. This is like your, I have a list of t's, a view, an array, a span, whatever you want to call it, and I want groups of them. I kind of like groups. Scala calls this grouped. Rust calls it chunks. I feel like grouping implies some sort of meaningful grouping, like by key, and so I went with chunks. But we're not here to talk about the name. So I had a to-do to factor it out, right? Because we originally just wrote it hard-coded on string in the puzzle, and I'm pretty happy with it. I did allocation hint for the size. I think the size is completely predetermined, so we don't even need to use a list here. We could use a raw buffer. And the only overhead here is just that capacity and the capacity check, length check. We'd still be doing bounds checking with buffers, so it's just a tiny bit of overhead to use like a pushable list, but it would probably be a bit cleaner because we know what the size is going to be. But that's beside the point. So I wrote it. It's just your simple loop. And I wanted to specialize it to string because I would like, the original use case was actually getting a list of strings chunked. So I went over to string.k1 and I thought, which is just a view of characters, right? So let's do def type string. Def type is string, right? So here in the built-in, like our preamble, it's just a view of char. And it's a very special struct. A struct with only one member is a pretty special thing in like zero cost programming because it's guaranteed to be the same thing physically as the field. And this is used for all sorts of new typing, like to enforce some invariance over the thing, just wrappers, new type wrappers, right? That we all know and love, or to attach a bunch of functionality to a particular version. Think of your it's used for IDs, for certain types of strings. You get the idea, right? So I actually thought, first I thought, it's the same thing. I don't really want to spend a lot of time on this. Let me just, transmute the thing. And I do have a to-do. So this needs to be a to-do. And we'll do like a no commit at like tier 3. We say like unnecessary pointer. We need a mem transmute function. So I can transmute pointers, right? References, like just change what it's pointing to, but I can't do it for values, which I would like to do here. And then the nice thing about a mem transmute function is it could statically assert that the lengths are the same, the sizes, and even the alignments. The size and the alignment should be the same. So it's like same layout, right? But I thought, for now, let me just throw in, first of all, I said I'd like to just I'm going to do this dirty thing where I cast it, but let's at least check that the size is the same. And I thought, I don't have a static assert, right? In Rust, I would write like static assert size, which you can like achieve through macro magic. So there's a macro rules static assert size, which I stole from the Rust compiler. And it's actually total hack. It uses these array literal types to sort of trick the compiler into asserting on the size. So, and I thought, I actually do, because I have static, and let's focus on this one. I have static assert, right? And, you can see the LSP here is saying, look, not that one. Let's do static assert equals +3, right? And boom, static execution exit. The print isn't working because I was doing something on prints, but there you go. We can check that it's the same, and I thought, but I can go further, right? Because it's not enough that they're the same size. What I know is that it's a single member struct, right? So I thought, this is actually something I want to build into the compiler. If if A is a type and B in foo is a single member struct of A, and A is of type A, or let's say foo is of type foo. Right, so I have a wrapper around an A. I would like to be able to write foo as A. And I think that I can add a case for casts specifically that understands that single member structs can be casted to their inner type. I guess this could just be foo.a. But you could just access the field. But the issue is when it appears inside a type like this, right? you know, we're trying to cast this outer type, and I want to be sure it's safe. So yeah, I have a view of chars, and I want a view of strings, right? So, you know, sticking with the pointer cast, trying to decide where I want to take this. I think putting something like that in the compiler that's new type aware would make sense. And it's more relevant when the types appear inside a collection or inside another type, when you couldn't just like trivially access the field to convert the value, right? But I thought, you know, I could actually maybe assert the thing that I really want to assert here, that string is a wrapper type of view of characters. So how would we even do that with a regular function? Well, any function can be called at compile time. So we can go with isWrapper type, and it's going to take 2 types. Okay, and no parameters, and that's going to be a bool. And what is it going to do? Well, I think that we want to get the type schemas of both of these things. So we're going to do like let schema A equal types get type schema in B. And then we'll say false. Okay, and it's false. And if we say true, we're all green. So we can kind of live code this, okay? Now we'll return false till we're done. And I'm going to require isWrapper type A, B. So I'm going to require that A, schema A, is a struct with fields. No, is a struct S. Else, we're definitely going to return false. And we could do a message too. Let's crash. Crash is wrapper type A must be a struct. Let's test what we've already written. Int. We're not getting our output because there's a different bug. Let me see if I can fix this quickly, because it'd be so much cooler if we were getting the output. So we'll build the LSP. It takes a little bit of time to build it in release mode. Sorry if I'm talking funny. It's very cold today, so my mouth's a little frozen. That's better, isn't it? So isWrapper type A must be a struct. All right. Back to string. Let's just print. I don't know what we're doing. This is meta programming. I don't know what this thing returns. S expected field name view but got fields. Field name view. So but got fields. So all right. So it looks like it's of type field, which is a view of these structs. So let's just say fields.length. s.fields.len. Is that allowed? A must be a struct still. Println schema. This will just be types get type name. I don't know. I do have a type kind. It's a string, right? What is its kind? I was working on something like that because it's an enum variant. Def type schema. So we'll look at our type schema type. String is its own. Oh, so this won't work for string. Shoot, because it's a special type. Oh, that's so disappointing. I literally intercept if the struct is string, because like you kind of want to work with strings. You want them to be kind of a first class thing. Oh man, I guess we have to rely on static knowledge here then. That's a bit of a bummer. Can we just pretend that it's anything but string? So let's pretend that we were using myString. You bear with me. And it had underlying chars. Okay, and let's say we're gonna return a view of myString. It's wrapper type myString. See, it has 1 field. And we'd like to transmute here. We wanna know that this is safe. So we'll do require s.first is some field type ID, and s.len is exactly 1, else crash. A must have 1 field. Let's match on fields instead. Let's pass something else. Let's pass a 2-field struct, b int. A must have 1 field. And we can just program got. We can just program got 2. Okay. Let field schema Now this time we're going to call a different function. This one takes a type ID. So we have a version that takes no value, as you can see, but takes a type generically. This is convenient to call. But if you have a type ID as a value already, then we're going to call this one type schema with our field type ID. No, it's the field actually, is some field. Field, and if we hover on field, we can see that it's name string type ID offset. So field.typeID, just like that. And now let's just, I don't know if they implement show actually, so we can't just print field schema, but let's just assert that they're the same type. We don't even need to. We have B's schema. We can do better. We only need A schema. Let B type ID. Okay. Assert equals field dot type ID. B type ID. Boolean, right. Assert is wrapper type. So we got my string, and it looks like it returned true. But what if it were a buffer of char? Well, those are different types. Now I don't really love just assert failed, so I kind of want the logic that assert equals gives me, because it would print the difference. But let's say, let's still return a bool, but let's do, if they're not equal, then let's just do something nice. Then we're going to print line expected but got, and then this is going to be, I can't do that. Types, type name of field dot type of B type ID. And this is going to be types type name of field dot type ID. And now we're going to return let equal. Now, I don't love printing here because we may be doing some other metaprogramming where we just want to check if something's a wrapper type. We don't actually expect it to be. So it's not the best. We can write another function, assert wrapper type. This makes sense since I was trying to write this anyway. Okay, how about that? And now I want to do assert with a message. I think I have it. Oh, but it builds the message. I don't like building the message. I don't like that function because I don't like building the message unless they're not equal. Can I just assert false? Let's crash. Let's crash with the message. Something like that. And then we're going to use get type name because we don't have the type IDs handy anymore. And this is our variant that takes the type generically. Oh, that's disappointing. We don't actually have the field anymore. Message, get type name, right? You don't take anything. So this is going to be the wrong message. Let's make it not a wrapper type. Assert failed. Assert wrapper type. Static, assert wrapper type. Expected view char, but got my string. Yeah, it's not exactly right because it's the full type. So we'd want to return a string from here. But maybe we just write it all as one function instead of trying to dry it up. We've still demonstrated what we wanted to demonstrate here. We needed a view of char. We got a buffer of char. View event, view of I64. Sure. All right, so there we go. We have a nice little. It's still not the safest cast because I could easily type the wrong thing here. This is not a final form, right? That I would do. And again, some of this is more first class. You'd want actual compiler help, I think, for the new type pattern. But generally this type of maybe safe transmute you could do with metaprogramming as well. And instead of a static, we could do a meta here that would actually produce the cast if it was safe. So yeah, I thought that was a nice moment that I realized that I could leverage the metaprogramming and type schema reflection in a really nice, convenient way that we've already built out. So leaning heavily on this require pattern match, conditional pattern matching with early exit that I think is really powerful on the sum and product types we have here, where we just have this really simple schema. You know, metaprogramming can sometimes be so complicated, but I mean this, and of course it'll accumulate more things as we support, you know, like maybe fields will get explicit align or, you know, weird more stuff on pointers, but you know, this is simple. And this is all you need. So, or this is as complex as it has to be to get really far, I'll say. So yeah, I hope you enjoyed it. I thought that was a neat use case for what I've built so far.